All right. Before we start our discussion of single replacement reactions, we are going to talk a little football. Okay. We have different positions in football, right? So let's say that we are talking about a roster here of quarterbacks. Okay. Let's put up Jordan Love at the top. And then who's the quarterback for the Badgers? Anybody know? Somebody's got to know. Come on, you guys. Let's have somebody that knows it. Chase Wolf, then. Looks like is he our current one? That's 2015. That's too old. You think he's current, this guy? We're going to say that he's the quarterback because I don't know. And you're like, Lippy, why does this matter? Just give me a second, okay? Just give me a second. All right. So we're going to say Wolf here. He's the Badgers. He is, of course, the Packers. Who's the quarterback for the Bears? Do you remember? He's really bad. Really bad.
This year?
Yeah. Peterman? Fields? I think it was Fields that played most of the year, wasn't it? So we're going to call him here because, you know. Sorry if you're a Bears fan. I'm saying that our Wolf was better than your Bears. Our Wolf was better than your Fields. And then we've got Craig's quarterback. And you got me. So this is your roster. This is what you get to choose for your quarterbacks to put in a game. Okay. Sometimes some of them show up, other times they don't. All right. So let's say that Jordan Love is your quarterback. He's playing in the game. And all of a sudden, this Fields character shows up and he wants to play his position for the Packers. Are you going to sit Jordan Love down on a bench and put him in? No, he's not as good. Why would you do that? That's silly. Okay. But now let's say that we've got Lippy. I'm the quarterback in the game. And now Wolf shows up. What's going to happen to me? Benched. Oh, absolutely. And I should be. Okay. I got a bad shoulder. Like I can't throw. I'm uncoordinated. It's ugly. Okay. It's still better than not having a quarter. Well, it may not be actually, but but it's still better than not having a quarterback, but it's still not a good thing. Okay. So yeah, any of these guys come along, I'm going to sit on a bench. Okay. If he's in the game, there's only one person that's going to replace him. That's going to be Love. Okay. Any of these other people show up and nothing's going to change. All right. Now, let me relate that. And I know you think I'm crazy. Okay. But let me relate this to equations. Okay. With our single replacement equations, they don't always run. And we're going to talk about where your roster is now. Okay. So if you flip over that reaction type sheet, you are going to see your roster listed there. Okay. So you are going to find lithium, which is what's trying to replace. Now, what is lithium going to replace here? Is it going to replace or try to replace the calcium or the chlorine?
Calcium.
Right. The metal can only replace the metal. Okay. So you're not going to replace like the where you would end up with two metals there. Okay, it doesn't work because then you have two positive ions. They're going to push apart. It's not going to work. Okay, so you have to compare that with, so you got to look and figure out, is this the metal or the non-metal? And then find the other one of those in the compound. So is this going to replace that? Well, where is calcium compared to lithium? Is it above lithium on the roster or is it below lithium on the roster? Okay, so calcium is down here. Calcium is in the game right now. Is lithium a better player on your roster? Then what's going to happen to calcium? What happened to Lippy? Right, it's going to get benched, so it's going to go sit on the bench, and lithium's going to come into the game with the chlorine. So calcium got bumped to the bench, and lithium came in. Now, with this, you have to go back and check your charges, okay? You're not going to bring those subscripts over. We talked about how naughty that was yesterday. Don't do it. You have to go back and reevaluate those oxidation numbers. And at this point, this guy is taken care of then, okay? So now we have our skeleton equation. We need to go about balancing this. This is where some of those training wheels for some of you might be coming off, because you might be able to go, okay, I got 2 here. I need 2 here. Now I need 2 over here, and you've got it balanced. For others of you, you still need the training wheels, and that's okay. So let's see how we're going to do that with the training wheels. I'm going to have my lithium, my calcium, and my chlorine. Here, lithium, calcium, chlorine. 1, 1, 2, 1, 1, 1. So I need 2 chlorines. That also gave me 2 lithiums. So I will go back over here, put a 2 there, and now I've got it balanced. Does that make sense in terms of the roster and how I'm relating it to the football and all of that good stuff? I know it sounds crazy. I know. But I bring it together, right? All right. So let's talk about, so that was team metal. Okay. That's your roster for the metals, for the team metal. You see that? We need to talk about team non-metal and where that roster is. Okay, because that doesn't appear on that same paper. Okay, what you are going to do is you are going to use your periodic table, and that is your roster, because we're only going to be doing these for halogens. So fluorine, chlorine, bromine, iodine, and AT. Okay. That's your roster. It appears in order. The same order is of the roster is the same order that it appears on the periodic table. Okay, so this is team halogen. All right, I have chlorine here. I have chromium 3 iodide. And we've got to see if this reaction is going to run. Okay, so this is team halogen. Look at your single item. Your single item then will tell you which one it's going to replace. So this is my non-metal. We're going to be looking at the other non-metal then. So we're looking on our roster to see if this guy is going to get replaced. So you find the one that they're trying to sub in. They're trying to sub this in. Is chlorine a better player than iodine? Yes. Then iodine's going to do what? Yep, we're going to put it on the bench. It's going to be by itself. How do I write iodine when it's by itself? Yep, I got to put a 2 down here because it's diatomic. Some Brinkelhoff. Then I'm going to bring my chromium in with my chlorine. And then I've got to reevaluate my values. So this is a +3. This is a -1. I need 3 of these then. Did I lose anybody? All right. Then I've got to go back and balance this guy. All right. I'm going to look here. I've got 2 of these and 3 of these. I'm going to look for the least common multiple between 2 and 3. What is it? 6. So I want to get this up to 6. I'm going to put a 2 here. Then I'm going to come back over to this side and try to get it lined up. So again, with this iodine, I'm going to look for the least common multiple. I'll put a 2 there. So that gives me 2 of these and 6 of these. I wanted to hold these. I call these things singletons. I wanted to hold them out to the end. Okay. Because it's easier to, that was one of your hints. Hold these single items out that are not in a compound. Hold them out until the end to balance because it makes it easier. All right, I got to get this guy up to 6. So I'm going to put a 3 here. And I got to get this guy up to a 6. So I'm going to put a 3 here. And now I've got it balanced. Okay. Is that making sense with your rosters, the analogies, the benching, the whole 9 yards? Merritt.
How do you know which one of them to replace?
You look at the singleton. So look at the single one in your reactant and figure out if that's a halogen. If it's a halogen, then it's going to try to replace the other halogen. If it is a metal, which lithium is a metal, then it's going to try to replace the metal.
Okay.
All right. So that takes care of where you've got a compound and an element. Okay. There are special cases, though, for metals and water. Okay, water is really common, so we have situations with that. And what I have done for those is on your sheet, I have a call-out box about halfway there that has 3 different situations in it. I think it's called D, and then it has 3 Roman numerals in it.
D1, D2, and D3.
Okay, so D1 and D2 and D3 on your sheet. Are you able to locate where I'm at on here? Okay.
No.
All right. Everybody with me? So you have to look at what metal is interacting with the water. In this first case, the metal is iron. So see if you can find iron in that listing somewhere. The first part is alkali and alkaline. Where are your alkali and alkaline at? What part of the periodic table? The first column is alkaline or alkali. The second column is alkaline. All right. So iron is not in there. It is a transition metal. So does it appear in D2 or does it appear in D3? D2. Iron is right here in D2. So it says when iron interacts with water, it's going to form what?
Metal oxides and
Okay, so what is my metal? Iron. So it's going to form what?
metal oxide,
So what is it going to form?
iron oxide.
Iron oxide. Good. Okay. So it's iron oxide plus what else? Hydrogen gas. Yep. All right. Now we've got to go back and we have to figure out what the oxidation numbers for this are. They gave us the oxidation number for the iron. That is a +3. Oxygen is a -2. So I'm going to need 2 of these for every 3 of these to get this to balance out. Once I have my formulas balanced, then I can start balancing my reaction. Okay, I have 1 iron, 2 hydrogens, 1 oxygen. Over here I have 2 irons, 3 oxygens, and 2 hydrogens. So I need to get, and I'm going to start by working with the oxygen because I want to leave my singletons to the end. Okay, so I'm going to start here. I want to get 3 oxygens. And that's going to take my hydrogens up to 6. Now I'm going to start attacking my singletons. Okay. My iron is here. I need 2 of those. My hydrogens, I need 6. So if I put a 3 here, then I've got that balanced. So as a review for that one, we had a metal with water. Metal with water, we're going to go to this call-out box. We're going to find where that metal sits in the call-out box. Okay. And then we just follow the directions from there about what it's going to form. All right. Let's go down to calcium water. We've got calcium plus H2O. Where is calcium located on your periodic table?
Alkaline.
Alkaline.
So
Okay. So column 2, that means that we're going to use D1 as our to determine what we're going to form. Okay. So we're going to follow D1. D1 says that we are going to form what? So what's my metal here? So what are you going to form? Calcium hydroxide. And what else? Hydrogen gas. You guys actually did this reaction in lab. Do you remember doing that? You put it in there and it fizzed and fizzed and fizzed. And then you're like, what do I do with it? I'm going to like pour it down the drain because you just made drain cleaner. Okay. And then the bubbles that you formed in there were hydrogen gas. So we could have captured those somehow. We could have made a big boom. You go boom. All right. Then we got to balance this. So I need to put a 2 here. And it's going to give me 4 hydrogens and then I'm balanced. All right. Now, what about a situation such as if we had, wrong mouse. Let's say that we had this reaction, but now we're going to look at the reverse of it. Okay. So I've got iodine plus chromium chloride. And we're trying to figure out if that's going to run. Iodine is lower on the list than chlorine. So is iodine going to go in the game? No. So we would just write down NR, which stands for no reaction. So if you're trying to sub in something that is a worse player, it's not going to happen. Nothing's going to happen with that. If you look, for example, at your metal chart, what's at the very, very bottom of that metal chart? Huh? Gold. Okay. And you're like, but Lippy, you told me that these are worse players down here, and gold is way down here. But I know gold is a precious metal. What else is down there? What's right above it? Platinum. What do you know about platinum as far as a metal is concerned? What's right above that?
Mercury.
Above that?
Silver.
Silver. Okay. Mercury we don't play with. It's a little dangerous. But these guys, what do you know about all three of those?
They're considered very valuable.
Right. Do you know why? Because they stay in their pure form. Nothing's going to interact with them and bump them out. It's not going to have a reaction with any of them. These don't have reactions, so they stay nice and shiny and bright and look like new. That's why they're precious metals, because they stay in their pure form. They don't interact with these other things and form other compounds. So that's your precious metals. And gold is more precious than silver, isn't it? Because silver will still react with a few things, like making your silver chloride when you were doing that reaction. You do that with gold, nothing's going to happen because nothing really reacts with the gold. So it stays in its pure form. So that's why I don't feel so bad about being down at the bottom of the list. Because nothing's going to bump it out. And that's why you have precious metals. Kind of cool, huh? All right, so that takes care of that one. Now we need to talk about combustion reactions. Okay, so combustion reactions, you guys already know how to do these. All right, oxygen, hydrogen, you're going to make water. Okay, so you know how to do those. Those are just single replacement reactions. We talked yesterday about the hydrocarbons and how you can easily solve for the hydrocarbons. Okay, so remember I gave you some hints for those. I said number one for balancing hydrocarbons. So this is balancing hydrocarbons. I said look at the carbon in the hydrocarbon. If it is odd, go to step 3. If it is even, go to step 2. Step 2, put a 2 for a coefficient in front of hydrocarbon. Number 3, balance carbons. Number 4, balance hydrogens. Number 5, balance oxygens. Number 6, look to see if you can reduce. And you're done. Those are the steps. And you guys practiced some of that the other day with those other equations, okay? Good.
No, not yet. Right.
So at the bottom, the very bottom of the back side of that sheet that you're on, okay, there are two different options. You are going to assume that all of these reactions are complete, which means that your products from these hydrocarbon reactions are always going to be what two things? What are the products in a complete combustion reaction?
Carbon monoxide and H2O.
Yep, CO2 and H2O. So every one of these that has a hydrocarbon, those are going to be your products every time. So if I'm telling you to assume that they're always complete, why do I even bother putting the incomplete one on there? What is the point of that? Why would I even share that with you? Here is why, and this is my PSA for the day. Okay. I put it on there because what is the other product other than water and carbon dioxide in an incomplete reaction? What is CO? What do we call that? What's the name of it? Carbon monoxide. What do you know about carbon monoxide?
Poisonous.
It is poisonous. It is also colorless and odorless. You have no idea that it is there. Okay. Your blood, the hemoglobin in it, your hemoglobin in your blood is what picks up oxygen from your lungs and transports it around your body. If given the choice, it is like Lippy and salad and chocolate. If given the choice, Lippy's going to eat what? Chocolate every day. Okay. Should I eat chocolate all the time? No, I should eat my salad. It's better for me. Okay. Just like oxygen's better for your hemoglobin. But if your hemoglobin is given a choice, it's going with carbon monoxide. Okay. So if you have carbon monoxide in the environment, your blood's going to pick that up and prefer that over oxygen. And that's why people die of carbon monoxide poisoning. Essentially, they're suffocating. It's like an internal suffocation because they're not getting enough oxygen in to their blood to be able to do cellular respiration and all of those other chemicals, apparatus that you need to have happen in your body. And so I put that on there so that I can talk to you about carbon monoxide. You should have carbon monoxide monitors in your homes, okay? Especially this time of year, you need to make sure that your vents from your furnaces are cleared, because if you get a buildup of carbon monoxide, you have no way of detecting that without a detector, okay? And you can die. This is why you always open up the garage door if you're going to heat up your car, because you don't want to build up of carbon monoxide in your garage, and you don't want to stink it up with the exhaust either. But nevertheless, most combustion reactions are incomplete. In here, for making life easier on you, we're going to have them all complete, but I want you to know about that reaction. It's an important one in your life. Okay. All right, sir. Yeah, just Minga. All right. So any questions on how to do any of this stuff?
That's just what we've been doing like the past few days, right?
Yep. So I am going to hand out your quiz then for today. You're going to take your quiz and then